Okay, hello and salam alaikum. Welcome back to another year with science, and we are going to be answering some questions for the upcoming quiz that you have on Tuesday. So we're just doing a quick review. But I do want to say as well that if you are unsure about some of the materials that we're doing today, this is not an explanation video. So although I will explain things briefly, if you want an extensive explanation video, the complete lesson will be found in the description below. Okay, so that lesson will cover the entire content much more comprehensively. For now, though, what we're going to do is we're just going to answer some questions to help you revise for the upcoming quiz. So let's just get on with it. Which subatomic particle has no charge? Which subatomic particle has no charge? Now remember we said those subatomic particles. What are subatomic particles? Subatomic particles are things like protons, electrons, and neutrons. There are three that you need to worry about. And they are the ones that atoms are made from. Okay, so atoms are made from electrons, neutrons, and protons. Now, electrons are negative, protons, protons, positive, and neutrons are neutral. So which one has no charge? Which one is neutral? And that one's going to be neutrons. Neutrons are neutral. So once again, neutrons are neutral, protons are positive, and electrons are negative. Okay, which subatomic particle has a positive charge? Well, we've just answered it. Protons are positive. Which subatomic particle is negatively charged? Hopefully everybody picked electrons. They're also the lightest. Which subatomic particle is the lightest? Electrons. So electrons are really, really light. So electrons only weigh about 1,840 times lighter than both protons and neutrons. So neutrons have a mass of 1 AMU. Don't worry about the AMU too much. And then protons have a mass of 1, while electrons have a mass of 1 over 1,840. So that means they're 1,840 times lighter than protons or neutrons. Who discovered the nucleus through the gold foil experiment? That is Rutherford, the New Zealand guy. Rutherford, okay? He did an experiment where he put like a really, really thin foil of gold, a sheet of gold, and he shot it with some alpha particles, which is like a powerful laser. And then he found that some of the particles or some of the laser was being bounced back. And the reason why was because it was hitting something that was very solid at the center of the atom, which we call the nucleus. The nucleus is the center part of the atom, and it's very heavy. Do you know why it's heavy? Well, it's heavy because it contains protons and neutrons. Okay? Who developed the model for the electrons in fixed orbits? So remember we have different models, right? And the one that said it was like a planetary model, where it's like a nucleus, and then we have these electrons all around like planets. Well, the guy who said that was Niels Bohr. Okay? Let's keep going. Which of the following is not a subatomic particle? Well, we heard about electrons, we heard about protons, we've heard about neutrons, but nobody's heard about bohrons. So that is not a subatomic particle. Which two subatomic particles are found in the nucleus? So which ones are found in the center here? Well, those are protons and neutrons. Which part of the atom contains nearly all its mass? Okay, so it's not the orbitals. Isotopes, that's not even part of the atom. That makes no sense. The electron cloud, no, because that contains electrons. That's very light. It's the nucleus. The nucleus contains most of the mass of the atom. Which part of the atom contains almost no mass? Well, that's the electrons, because they are very, very light. Okay, so that was okay. Let's keep going. Okay, in this case, we have to try and fill in some blanks. Let's have a look. Complete the missing values. So we've got the atomic number, the mass number, the protons, the electrons, and neutrons. Well, the first thing you need to know is that the atomic number is also the number of protons. So that's all that is. That's just a fancy way of saying number of protons. So the atomic number is always going to be equal to this number. So this thing here is the same as this thing here. So that's the first thing you need to know. So if that's 7, that's 7. If that's 8, that's 8. And if that's 9, then that's 9 because the atomic number, remember, it's the same as the number of protons. And that's 16, so therefore that's 16. Now, the next thing that makes it easy as well is that in a neutral atom, which is like normal atoms, there's no charge. And if there's no charge, it means there's the same number of electrons as protons. So if we have 7 protons here, then we have 7 electrons. And if we have 9 protons, then we have 9 electrons. And if we have 16 protons, then we have 16 electrons. So that's really easy now. Okay, so what about the mass number? What is the mass number? Well, remember how we said the nucleus is the heavy part of the atom? Well, the nucleus contains protons and neutrons. And that's exactly it. That's the mass number. So we just have to add the protons and the neutrons. So let's have a look. That's 14 because it has 7 protons. See, 7 protons. And how many neutrons? Well, it's 14, so it has to have 7 neutrons. What about this one here? That's 16, so it must have 8 protons and 8 neutrons because 8 and 8 equals 16. What about fluorine? Let's have a look. So fluorine has 9 protons, and it has 10 neutrons. So that means the mass number is going to be 10 plus 9, which is 19. Okay, and that's it. We're done. How easy was that? You just have to know that atomic number is proton number, and mass number is both protons and neutrons. That's all. And the rest of it is easy. These guys are always going to be equal in a neutral atom. So that's going to be equal to that, and that's it. Like the only one that might be slightly different is the neutrons. But you don't even have to worry about learning it. You just have to do the maths. Okay, so what is the difference between atomic number and atomic mass? Well, atomic number is going to be number of protons. I apologize about my handwriting. It's just really hard to write on this pad. And then mass number is number of protons and neutrons. Don't forget the and neutrons. So that's it. That's the difference. Okay? What is an isotope? Well, isotopes are atoms of the same element with the same number of protons but different number of neutrons. So that's all it is. So they are the same element. So isotopes are atoms of the same element. So if it's oxygen, it could be oxygen. You've got oxygen 8, you've got oxygen 16, you've got oxygen 17, but it's always going to be oxygen. If it's carbon, then it could be carbon 12, carbon 13, carbon 14, but it's always going to be carbon. So an isotope is the same element. It just has a different mass number or a different number of neutrons. So isotopes are atoms of the same element that have same number. Oh my god, my handwriting is terrible. Because I'm using this, by the way, and it's just still getting used to it, okay? So just bear with me. It's quite hard. Same number of protons, but different, oh my god, different number of neutrons, or different mass number, because of course if you have different number of neutrons you have different mass number. Okay. Oh my god, I hope you can read that. It's very hard to read. So it's isotopes are atoms of the same element that have the same number of protons, because you can never change the number of protons. You change the number of protons, you change the atom. However, you can have different number of neutrons. And so, for example, you can have carbon 12, which means it has 6 protons and 6 neutrons. Or you can have carbon 13, which has 6 protons and 7 neutrons. Okay? And likewise, you can have oxygen 16, which has 8 protons and 8 neutrons. Or you can have oxygen 17, which has 8 protons and 9 neutrons. Okay, what are the two subatomic particles that determine the mass number? Well, hopefully by now you should know. Mass number relies on protons and, okay, we don't have to write that fancy ampersand. We can just say and neutrons. Okay, and let's answer this diagram here. The diagram shows a boron atom. Number of electrons. Well, we can just count, can't we? 1, 2, 3, 4, 5. There you go. 5. What about the number of neutrons? Well, again, we can try and count them. 1, 2, 3, 4, 5, 6. Because remember, they have a charge of 0. And what is the mass number? Well, the mass number is going to be both protons and neutrons. So we can just add, because the number of electrons is equal to the number of protons. So we know that it's going to be 5 protons as well. So we can just add these two, which is 11. Or we can just count them. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So it's just 11. And that's it. Easy. Well, I don't want to keep it long. That's all you need to know. And if you have any other questions, of course, feel free to ask your friends. And if you're still not sure, you can email me or you can send me a message on Teams. Yeah, all the best. And remember, if you're not sure about the lesson, watch the full lesson video in the description. Adios. Over and out. Ciao.